So in our previous example, we showed how an apple falls on the floor, and you may be thinking, how is an apple falling on the floor related to electrons and atoms? You may see that an apple is attracted by the earth, but you may not see any other connection. So we will show another example that it starts looking like an atom. In this case, we will picture the solar system, and in the solar system, it's a very simplified solar system, we will look at how the Earth and Venus are attracted to the Sun. Maybe you don't know, or you already know, that Venus is closer to the Sun than Earth, but Venus and Earth have very similar masses. So how is that related to their potential energy and the attraction? Well, the moment Venus is closer to the Sun, it means it has a more negative potential energy, negative potential energy, and Earth has a less negative potential energy. Notice that zero potential energy would imply to kick Earth out of the orbit from the Sun. So as you move Earth away and away from the Sun, the energy will get closer to zero from the negative side. So we see the same kind of interaction. The energy of two masses interacting because of gravity implies the masses interacting and the distance. This means that the higher the masses, the more negative the energy is. Or I should say, the higher in absolute terms, if you will, your energy is, the more negative it is, okay? But the higher the distance, however, the lower your energy in absolute terms it is, okay? So think, provided that Earth and Venus have similar masses, the only thing that changes is the distance from the Sun. So this could be, at this distance of Earth, and exaggerating a little bit, this would be the distance of Venus. Venus is closer, so the distance is smaller. This will be the energy of Venus, potential energy of Venus, and this will be the potential energy of Earth. So you see now that the energy of Venus is more negative. It's larger in absolute terms, but it's more negative. This means that it's more attracted. The more negative your energy is, more attracted. So okay, you can think of the slope. The slope gets stronger as the distance gets smaller. Right. So let's again run a simple question, as we said. So Venus has a higher or lower potential energy than Earth. In absolute terms, the energy of Venus is lower, is more negative. All right, so it's a lower potential energy than Earth. Venus has a more or less negative, we just said, is a more negative potential because it's closer. Venus, is it more or less stable than Earth? Well, in this case, we said, and let's just go over it again, that the lower the distance among attracting particles, it'll mean that the energy is more negative, okay, and this will mean that the higher is the stability. In other words, if the Earth were not for the fact that it's traveling at such high speed, it would keep falling closer and closer to the Sun. So if you were a semi-god able to stop the Earth from moving, the very attraction of the Sun would make the Earth closer and closer until it collapses with the Sun. All right. So the closer or the farther a planet is from the Sun, the lower its energy. Well, we just said here that the closer, as it gets closer and closer, the energy gets smaller. It gets more negative. So the closer the planet is from the Sun, the lower its energy, the more negative the energy is. So is Venus more or less attracted by the Sun? It'll be more attracted. So the lower the distance, the lower the energy, the higher the stability, the higher the attraction. Okay? If you think of the attraction as the slope, and those of you who've taken physics maybe remember that the derivative of the energy versus distance is the force. If you remember, actually there's a negative sign. So the higher the slope on this curve, the higher the force, the higher the attraction. All right. So the potential energy change if Venus were to move 1,000 kilometers closer to the Sun, is it higher or lower than if the Earth were to move 1,000 kilometers? Well, notice, and again because of the Sun, a change in 1,000 kilometers from here to here will involve a larger change of energy than from here to here. So it means because it's closer, not necessarily the rate of change, but the slope will have a more dramatic change in energy. So it'll be a higher change than if the Earth were to move 1,000 kilometers. Okay. So does it take more or less energy to kick Earth out of orbit than kick Venus? Well, we just said that Earth is closer to zero, so the necessary energy to kick it out of orbit is less because it's less attracted. So it'll take less energy to kick Earth out of orbit. So just going through this trend, the lower the distance, the lower the energy, the higher the stability, the higher the attraction, and the harder it is to, if you will, kick out of orbit. This will be important for electrons because that's how you ionize. So it'll be the higher your ionization energy will be. Okay. All right. So hopefully that makes some sense.